Hello all, welcome to this online recording sessions in data science. So in this session, we are going to see one of the most important topic in data science, that is transformers. So what are transformers? So what are the things that we need to know before learning about transformers? So how transformers can be extended into other platforms? Okay, so all those things we are going to see in this session. So okay, let us see how this transformer is getting evolved. Okay, yeah, so these are the below two lines. Below two, there are two links I can suggest. You can open these two links and go through what it is trying to share about the transformers. Okay, so this is one of the blog, J. Almer. Who is the J. Almer? J. Almer is the author of O'Reilly books. So he has written some books in the, published by O'Reilly. So he's a very good author. So he has written uh, this blog about transformer, which is very easy to understand for a unknown person or a very common person also, who is unaware about data science concepts also can understand if you read this blog. Okay, so I suggest you to go through this blog. Okay, and there are code part also, implementation part of the transformers that you can go through this with this link. Okay, so before going to transformers, so what are the prerequisites and what are the things that we need to know before transformers? Means I can share you first. If you want to develop an LLM stands for large language models, right? So right now this is very trending, right? So in order to learn LLMs, we need to know about transformers. Okay, we need to know about transformers. So to know transformers, we need to know attention mechanism. Attention mechanism. Okay, to know attention mechanism, we need to know sequence to sequence models. Okay, how sequence to sequence models perform. Okay, to know sequence to sequence models, we need to know to know sequence to sequence models, we need to know about RNN. RNNs like LSTM, GRU, like this. Okay, so this is the steps that we need to follow if you want to learn about large language models. Okay, if you want to develop a huge corpus of text, huge bulk text that in that LLM concepts involves. So this is the chronological order that we need to follow step by step in order to learn this. Okay, so here I can suggest before attention mechanism, sorry, after attention mechanism, we can, there is one concept called attention is all you need paper also. So attention is all you need also paper that you need to refer after knowing what is the attention mechanism, how does it perform. Okay, so in my previous session I have discussed what is RNN, LSTM, GRU. So LSTM, GRU are nothing but the special type of RNNs I have mentioned, right? So I have also shared sequence to sequence models. What are different sequence to sequence models, like one to many, okay, many to one, many to many. So like this sequence to sequence models also there. So in sequence to sequence models, what is happening? We need to give one word by word differently. Okay, but whereas in transformers, what you will you can observe, you can give bunch of text. Okay, so you can give whole sentence at a time instead of words. Here we'll give words, but in transformers, what is the advantages? What is the advantage means, I can say you can give the entire sentence or the entire bulk of text you can give in the transformers. Those that transformer will encode the input and then it passes to decoding, then it decodes the output. Okay, so this is the steps that you need to follow. Okay, so now let us see. Now let me share some blogs that are very useful. Okay, So how we need to know? Okay, so I will try to share you one good blog. Yeah, this is the good blog that I have found from the internet. So large language models from scratch. Okay, you can type this author name also. This is also very good blog I have found. So here you can see what are the steps if you want to learn LLMs. What are the steps you need to know? Okay, so what are the prerequisites that he all explains on auto encoding, label encoding, so distance between them, so what are word embeddings, so CBOW, skipgrams. Okay, so word embedding involves cbon, skipgram, right? cbon, uh, CBOW and skipgram. Okay, this is uh, okay. So now let us see so how these word embeddings are performing. Okay, okay. So word embeddings are all nothing but it involves techniques like word to vec. Okay, word to vec. Again, this word to vec is classified into based upon deep learning. We have some techniques based on vectors. We have some techniques. Okay, so based on deep learning, we will be having CBOW and skipgrams. Okay, in word embedding. Okay, so this is the prerequisite that we need to know about word embedding. So word embedding, that is nothing but word to vec. Okay, before knowing about transformers. Okay, so next you need to see, yeah, I have mentioned this techniques, right? Next you need to know about RNNs, how they functions. Okay, how they function. So what how input is taken in RNN, how they are processing it. So entire functionality of RNN you need to know before knowing about transformers. So this is the chronological order. So I'm coming in a chronological order as I've described to study transformers. Okay, so if you directly study transformers, I think you may miss some concepts and you may not full-fledged get knowledge about transformers. So that's why I suggest you to go and take an approach, this chronological approach, okay, to study about transformers. Okay, yeah. What are sequence to sequence models? One to many, many to one. We have seen, right? So these are also some deep learning models that take sequence of items as an input and output another sequence. Okay, sequence to sequence models. Yeah, attention mechanism. So after sequence to sequence models, during that sequence to sequence models, we have came one drawback. Okay, so to overcome that drawback, attention mechanism has came into the picture. So here in attention mechanism, what we will have, one encoder and decoder concept will come in attention mechanism. Okay, so encoder will encodes input. Okay, decoder will decodes output. So from encoder it will come, the output from the encoder will come to decoder. Okay, so this decoder will decode the output and it will give us the result. So this is what about attention mechanism means. Okay, where encoder decoder comes. Okay, so next attention mechanism, we have seen attention mechanism, right? Then there comes the, so what all happens, so what are the drawbacks in RNN, so how it comes into how attention mechanism is solving this issue. All this is described in this paper. Okay, so you can see how it is applied step by step in detail. You'll get to know from this blog. Okay, attention, these are all the steps. Okay, attention steps. So from this attention steps, it slowly is getting involved to transformers. So how this transformer concept came from the research paper, attention is all you need. Okay, so from attention is all you need research paper in 2017, this transformer concept came into existence. Okay, So it is proposed by some good authors. Okay, so you can check the authors names also. I think 4 to 5 authors are there. You can see it here in the research paper. Okay, this is the attention is all you need research paper that you need to know. It is published in 2023. So from this research paper, the transformer concept has evolved. Okay, so after knowing all this concept, then only you can go to LLMs, large language models. Okay, so now let us see how the LLMs will perform. Sorry, how the transformer is there. Okay, yeah, as I mentioned, encoders and decoder concept in attention mechanism, right? But in attention is all you need mechanism paper, which I shown recently, it consists of 6 encoders. 6 encoders and 6 decoders. You can have any number of encoders and decoders stacked one top of the other. Okay, but in this research paper, so we are trying to learn in comparison to the attention is all you need research paper. Okay, I hope you are getting me. Okay, so we are studying in context to that. We are trying to understand in context to that research paper, because in that, from that research paper only, transformers concept has evolved. Okay, so in that research paper, it is discussing about 6 encoders and 6 decoders. So you could see this is the input that the user is giving. Okay, and this is the output. Okay, that the user is getting. Okay, I think it is a language translation, French. Okay, from French to English conversion. Okay, here you can see from encoder it is coming to decoder. Okay, 6 encoders, 6 decoders, right? 6 encoders, 6 decoders, right? So now what we will do, so next slide we go. Yeah, let us see what is encoder and what is decoder. Okay, so encoders is composed of n equal to 6 in this research paper, as I mentioned. So it has 2 components. Encoder has 2 things in it. So one is self attention, the other one is feed forward. Okay, encoder block has 2 parts, self attention and feed forward, and decoder block has 3 parts, self attention and feed forward. Okay, it is similar to encoder, but in between, if you observe, we have encoder decoder attention mechanism is applying here. Okay, in decoder part. So rest these two are same as the encoder block. Okay, so only the difference is multi-head attention is getting added in between the encoder blocks. Okay, in decoder. So that is the only difference you could notice in encoder and decoder. Okay, yeah. So let us understand the encoder block steps. Okay, so before that, let us go to the transformer architecture, full architecture, how it is looking. Okay, so let us, yeah, so you could see this is the entire architecture of transformer. So the first, you can consider the steps also. The first step is positional encoding. Okay, the second step is multi-head attention or self attention. So self attention, if it is extended, we'll get multi-head attention. Okay, so then we have encoder part. So this entire is encoder part. Okay, so in encoder part, multi-head attention is the heart of the, you can call heart of the transformer. Okay, because it is the one of the most important component in the transformer. That is nothing but a multi-head attention. Okay, so third part is encoder. Next, the fourth part is decoder. Okay, so the entire transformer can be like this. Okay, divided into components. Okay, so here multi-head attention is there. Here softmax linear is also there, okay, on top of decoder, okay. So now let us see the internal parts of the encoder and decoder, okay. This is how the transformer looks. We are studying the encoder part. So after studying each individual block, encoder and decoder block, then we will again come back to the transformer block, okay, transformer architecture, and then we see the steps, how it is, how the input is getting, and the how output we are able to extract, okay. Yeah. First one, self attention. So what is the self attention? I said self attention is the, if you extend self attention mechanism, we can call it as multi-head attention, okay. If it is applied to multiple sentences or multiple inputs, okay, then it is called multi-head attention also, okay. So this is the heart of the transformer I have mentioned, right? So in there are sequence of steps that you need to follow before understanding this self attention mechanism. What is the step one? We need to define 3 vectors, okay. So what are those vectors? Q, K, V, okay. Query vector, key vector, and value vector, okay. So these 3 vectors you need to define them first, okay. Okay, then the next second step, what you need to do? Calculate a score, okay. You need to calculate the scores for what is Q value, what is K value, what is V value, and what is output. Combining all these 3, what output we will get, okay. So we'll calculate the score, okay. So I think I'll take one example to show all this, how we are calculating, how this calculation happens, okay. Second step is calculating the score. First step is you need to define this, okay. Define these 3 parameters. Second step is you need to calculate the score, okay. Score for Q value, K value, V value, okay, with the comparison of the input, okay. Next, third and fourth step, what it will have? You can take this formula, okay. So we'll calculate, we have calculated the scores in second step, right? So with that scores, what we will do in third and fourth step, we'll multiply Q and K vectors, okay. Q and K value we will multiply, okay. Okay, then divide by the root of dk. What is dk? It is the dimensional vector, okay. So in this transformer we can take any dimensional vector, but here we are taking root 64. What is the root 64? It is 8, right? So we will divide Q into K by 8, okay. Our vector will be 8 here, okay. Divide the score by 8. That's why we will divide by 8. So we have finished Q, K, right? Then we have V value. So that V value will multiply here, okay. So on together, after calculating this Q, K and dividing by 8, we also multiply with the softmax value, okay, to filter out and to make our values ranging between the scale value. So okay, to make all our scores in positive, okay, ranging from 0 to 1. So we will add softmax function, okay. We'll multiply with softmax range also, okay. So this is how we will get the z value. So z value will get by multiplying Q, K value divided by 8, followed by multiplication of softmax value and V value. Then we'll get a Z value, okay. So in the fifth step, what we are trying to do? Multiply each vector by the softmax score, okay. Okay, so after performing this, we are calculating softmax function in the fifth step. In the sixth step, what we are trying to do? Sum of the weighted vectors, okay. This is what entirely happening in the, this is what it is happening entirely in the self attention. Okay, you can see this example also. Okay, yeah, you are adding q into k. Okay, first step we are calculating defining q k v. Second step we are calculating scores. In third and fourth step we are multiplying q into k divided by 8. Okay, in fourth step we are adding softmax function. Okay, so we are adding softmax function in order to bring back the into specified range of vectors, right? So within 0 to 1. So and then v value also we are multiplying to it. Okay, we'll get z value. So here is the formula. Okay, so if this attention mechanism is applied to multiple sentences or it is elaborated, then we'll have a multi-head self-attention. Okay, that I'll talk later. Okay, then we have the other part, that is feed forward network in encoder part. What does this feed forward network will do? It is a fully connected layer that refines the transformers the attention of output. Okay, so that means it will connect the layers and refines and transforms the attention output. Okay, so it will transform the output to the decoder, this feed forward network. Okay, these two are the components that are present in the encoder block. So next, you understood these two blocks, right? So between these two blocks there is a multi-head self attention in the decoder part. Okay, that means same self attention mechanism, only it is elaborated in the decoder part. Indirectly it is conveying that only. Okay, it is focused on the other tokens in the sequence, determining the relevancy dynamically. Okay, so these are the advantages of multi-head attention. Okay, in decoder part. Okay, it explains the model's ability to focus on different positions. Okay, it will calculate different positions. We have sentence, right? We have big sentence like this. Okay, so it expands the model's ability. So whatever the model we are designing, whether it is encoder model, whether it is decoder model, or whether it is a combination of encoder and decoder model, that in that model it will try to focus on different position. Okay, the sentences. Next, it also gives the attention layer multiple representation subspaces. Okay, so these are the two advantages of multi-head attention, which is present in decoder. Okay, so now what we will do, we'll combine this encoder block and decoder block to get a transformer. Okay, that looks like this. Okay, so what is happening here? Positional encoding, first step, as I mentioned. Okay, so input is given, then the first step it is happening in the transformer block after combination of encoder and decoder is positional encoding. That means in to our sentence we will add positions so that it will not overlap, or it will be in a ordered wise. Okay, so we will be giving positions to the our text, then that text after giving position will be passed to self attention. Okay, or multi-head attention also you can call. Okay, so I have described what happens in multi-head attention, q, k, v value, all those 6 steps will happen. Okay, so after that it is getting passed to feed forward network. Okay, then after that it is passed to decoders. Okay, so like this it is extended to 6 encoders and 6 decoders, then only the outputs are extracted. Okay, so this is a decoder. Okay, okay, then you can see what is this add and normalization. So these are nothing but residual connections and layer normalization. Okay, these are residual connections and normalization. Okay, so that means our vectors will be normalized here with the help of this. Okay, this is extra. Okay, that is getting added on top of the block in the block of encoder block. Okay, it is getting extended in the transformer, you could see all this. Okay, Okay, you can see what feed forward network will do. Okay, so from this it will passing to decoder. Okay, so what the decoder will do, looks at the previous tokens. Okay, q, k, v values. Okay, from the decoder state. Okay, then decoder encoder attention will happen in between. Okay, in between decoder encoder attention will happen. Here purely decoder attention will take place. In between decoder encoder attention will take place. Yeah, you don't, yeah, you just need to be clear. Okay, so previously I have explained encoder decoder block, right? So but after combining those encoder and decoder block and adding some parameters, we will get a transformer. Okay, we'll get a transformer. Okay, so in this transformer these extra parameters are getting added. Okay, to make it clear. Okay, so in decoder encoder attention will take place. Okay, and these are the same, you know, about softmax and linear also. Okay, yeah, so these are the parts that I have discussed. Okay, transformer, what are the parts that it has. Okay, yeah, if you look into this is how the internally it happens, how the calculations will happen, as I discussed, right? So you can see all these things in the this blog only, JLMR blog, who is the author of Orally I have mentioned, right? Yeah, you could see all this mechanism. You can watch that video also. Okay, otherwise let me click the link from here itself. I have a link, right? So you could see GIFs also. Yeah, from that only we have taken reference, and with the help of some blogs we are discussing in this session. Okay, yeah, you could see what first step, what is getting happened. Okay, okay, so if you are knowledge with what I have said, then you can go in detail with the example. Okay, so how with the help of example you can calculate vectors and try to know. So you can see q and k value. So what are the q value, what are the k value? So we are getting 112, right? Then we will divide it by 8. So after dividing by 8 we will get 112 divided by 8, we will get 14. Okay, that 14 is multiplied by softmax. This is the second step. Okay, and self attention mechanism. Okay, so for a thinking word it is happening like this. Okay, so you take one sentence, you refer this JLMR blog and try to understand. Okay, so we are dividing by 8 means we are getting 14. So that 14, if you multiply with softmax function, so what it will happen, you could see here. Okay, yeah, so same thing, same mechanism what is happening here, you could understand in the form of matrix also. Okay, you can take matrix, each matrix row value and column value will be occupied with input text, and how the values are getting calculated. Okay, so you can refer this also. Okay, then how it is getting multiplied and how we are able to get it. Okay, so it tension head is applied to 7 times. So you can refer, so for detailed with example purpose you can refer this blog, very good blog. Okay, so many people are taking reference from this to understand the attention mechanism research paper. Okay, I think this blog was written by him after reading that research paper that he has mentioned in this blog. Okay, so that's why I request you to go to this blog and explore in detail with the help of example. Okay, okay, so now we see the, yeah, these are the internal things that are happening. So finally this is in matrix form. So in that JLMR will show in two forms. So normally he will show how the multiplication, how softmax max will be added. So then later on we will be applying matrices. He will be showing with the help of matrices. Okay, so how it will happen, how z values are calculated from this q, k, v. It's like convolution. Okay, So how we are trying to flattening. Okay, so from flattening, how we are trying to get a neuron, similar to like that. Okay, we are having bunch of layers. So from that we are trying to flatten it. Okay, we are trying to pulling and all will takes place. Okay, so after that we are trying to bring it like a neuron. Okay, similar to like that. Okay, this all will happen. Okay, yeah, what are the position encoding I have seen, we have discussed, right? Yeah, so there are different models, there are different large language models that have been developed with this mechanism, transformer mechanism, right? So we have seen three parts. There are three parts. Okay, so LLMs are designed with the combination of three types. Okay, so what are those three types? One is purely encoder, one is purely decoder, the other one is the combination of encoder and decoder attention. Okay, so I can say encoder attention, decoder attention, encoder decoder attention. Okay, so using these three variations, LLMs came into existence. Okay, so for if you see the decoder, so purely decoder, for what it is used? It is used for text generation. Okay, purely decoder, that means no encoder is involved in that. Okay, so purely decoder blocks are used in LLMs for text generation. We have models like GPT, GPT-2, GPT-3, GPT Neo that have already came into market, right? And purely encoder, okay, purely encoder, that is used for classification and summarization of text. Yeah, I have referred so many blogs and brought this conclusion. Okay, I think it will take some time to get this conclusion, so that's why I feel this is important point to share with all of you, right? Okay, so with purely encoder, we have some LLM models like BERT, Robota, XLM, Alberta, etc., DBERTA. Okay, so these are purely encoder models. Okay, purely decoder attention or purely decoder models, GPT. Okay, so combination of encoder and decoder combination is used for translation. Okay, so some of the models like TS, BART, M2M100, Big Bird are the LLMs that came into market right now. Okay, so there are three types and different models came into market, right? So I hope you understood and got some idea. Okay, from attention is all you need research paper, from J. Almer blog, and from my research into different blogs and research into this topic also. Okay, so there is one more important transformer that you could see, that is vision transformer. Okay, so vision transformer is used in mainly in computer vision for video processing. Okay, so like this many transformers have been evolved. Okay, and many LLMs are also came into existence with this transformer concept. Okay, so you can explore this vision transformer is also, and you can study with the help of research papers. Okay, so these are all the research papers that you can go through. Okay, so I have seen a few of these research papers. Okay, so to understand more about the applications of transformer, you can go through these research papers. So you can see sequence to sequence models I have discussed previously, CBOW, skipgrams, RN and LSTM, GRU. Okay, all. I hope you got the clear understanding of transformer and how it getting evolved to LLMs, right? Okay, thank you all. Thank you for this opportunity. Thank you.
Like, share, comment, and subscribe VNR Digital Learning Resource YouTube channel.